Hello students, welcome to Engineering Geology classes. We will start with the module 5, that is Geodesy. In today's class, we will discuss the very important concept, that is the remote sensing, the concepts involved in it, the applications of remote sensing and its limitations. So let us understand what is mean by remote sensing. So the word remote, you might have heard, we in daily use we come in contact with the remote controls we use, right, to operate TVs, then ACs, right. So why it is given name as remote control? Because it controls all the operations from a distance without being in contact with the object. It may be a TV or a AC. You need not have to touch that device and then operate the things. So without coming in actual contact with the object, you can operate the things. So we call it as a remote. So here also it is related to sensing, right? Remote sensing. So what is that remote sensing? We sense the data, or it acquires the data for deriving information about any object or a phenomena without coming in actual physical contact with that particular object. That is called as the remote sensing. So this is the image you can see here, the satellite image, right, wherein you can clearly see the river, right. Here is the river, then this is the reservoir, here again the river, this is the land, okay, this is the ocean, right. This is a Karnataka border, right, the Karwar, Ankola you can see. So this is the coastline, okay, and this is the land and this is the water body. So this is how the remotely sensed images they look like. So we'll see how it started, okay, what are the phenomena happening during the process, okay. So the remote sensing is what? The acquisition of data, okay, acquiring information about a phenomena or an object or a surface while at a distance from it. So we, without being in contact with the object, we can sense the data, we can acquire the data. So that is called as the remote sensing. So this remote sensing is a multidisciplinary activity that deals with the inventory, monitoring and assessment of natural resources through the analysis of data which we obtained from the observations which are made by the satellites or aircrafts, okay. So remote sensing is a method which is, or it is a method which employ the electromagnetic radiation. So it is based on what? The electromagnetic radiations which are emitted by all the objects, right, and we collect that information about that object with the help of electromagnetic radiations which are emitted by the object. So this name is attributed to the recent technology in which the satellites and spacecrafts are being used for collecting the information about the Earth's surface. So this was an outcome of the development in various technologies in the fields from 1960 onwards. Then we started with this remote sensing in the beginning with the help of a kite, okay, and the camera mounted on the kite. Then we started with the pigeon mounted cameras, then hot air balloons, then jet aircrafts, and then the aeroplanes. So this is the journey how the remote sensing has started. So remote sensing, that is studying the interaction of the electromagnetic radiations with the objects. The objects may be land, water, atmosphere, etc. All these come under the objects which are under observation. So understanding the properties of electromagnetic radiations which are emitted by the objects under various conditions, that is the fundamental of understanding the remote sensing. To understand the remote sensing processes, we must know the electromagnetic radiations. So the little about the history of the remote sensing, that is the first photograph was taken in 1827. So that is in 1853 the first aerial photograph from hot air balloon was taken. Okay, then this technology was used in American Civil War in 1861-65. Then in 1888 rocket cameras came up. Then in 1903 the pigeon mounted cameras they patented, and then from 1914 to 1945 onwards the plane mounted cameras we started using. So this was the first aerial balloon hot air photograph, okay, of Paris, okay, that was taken from hot air balloon, okay, in 1858. Then came the pigeon mounted cameras, right? So pigeon, when it flies over an area, the camera, it captures the images. Okay, so this is San Francisco from a kite mounted camera. You can see there is a kite and here is the camera mounted on it, and it was taken in 1906. Then the first flight, okay, when the Wright brothers they invented the flight, okay, in 1903. The first photo from an aeroplane was taken in 1908, and this is how the history began. Okay, so these are the different brief history of remote sensing. Okay. Then the NASA, which is 1967, the Earth Resource Technology Satellite Program, it started, and then onwards, okay, we have launched many of the satellites, okay, which are evolving around the Earth. Okay, so this technology, okay, there are two main types of remote sensing, you can say. One is passive remote sensing and one is active remote sensing. So passive sensors means what? They detect the natural radiations that is emitted or reflected by the object or the surrounding areas. You take for example your mobile camera itself, right? So sometimes you on the flashlight, and sometimes when the natural light is available you don't on the flashlight. So that is nothing but the passive sensors. So when the passive sensors is camera without flashlight. So passive sensors, they detect the natural radiation that is emitted or reflected by the object, and the reflected sunlight is the most common source of radiation of energy, right? Sunlight. Okay, so then the passive remote sensors, they include the film photography, infrared, then charged coupled devices and radiometers. They are used to illuminate the object. Then active means what? Active collection or active sensors. Here we need to supply the additional flashlight, right? So the radiations that is reflected or backscattered from the target when you scan the object or the area whereupon a sensor is placed, and then it detects the object. So like radar and lidar are the examples of active remote sensing, where the time delay between the emission and return, that is measured. Okay, and that is how the objects are sensed in two ways, that is passive and active remote sensing. So this is a very important concept, that is the components of remote sensing. That is very important question from exam point of view. So what are the components? So the first one, that is the A, you can see here, that is the energy source or illumination. Then second one is the atmosphere, radiation and atmosphere. Then third is the interaction with the object. Then the recording of energy by the sensors, okay, and then the transmission, reception and processing, that is done here, okay, and then the interpretation and analysis, then lastly application. So here these are all the components of remote sensing. You can see here the first source of energy, that is the sun, which illuminates the object. So when these radiations are coming on the earth, it will come in contact with the atmosphere, right? So there is an interaction with the atmosphere, then they reach the earth, the object, okay, then those are sensed by the sensors, okay. Then in case of radar, okay, that is the active sensors, what is done, this radars, they send the light to illuminate the object, okay, and then again it will be backscattered, and that is sensed by the sensors, okay. Then the recording of energy is done by the sensors, okay. Then it all the information is transferred to computer, right? There it is processed, and finally the human brain, it will interpret and it will analyze the things, and then we have to apply, okay. So these are the components of remote sensing. So we'll see one by one what are those components. So in much of the remote sensing, the process involves an interaction between the incident radiation and the target of interest. So first one is energy, that is the first requirement of remote sensing, that is the light energy or energy source which illuminates the object, okay, and it provides the electromagnetic radiation to the target of interest. Then the radiation and the atmosphere. So as the energy travels from its source, that is from the sun to the target, okay, it will come in contact with and it will interact with the atmosphere in which it is passing, okay. So this interaction may take place a second time as the energy travel back from the target to the sensors, okay. Then the third point is interaction with the target. So once the energy makes its way to the target through the atmosphere, what happens, it will interact with the target, and depending upon the properties of both the target and radiation, the energy or the information is sensed. Then the recording of energy by the sensors. So once the energy is backscattered or transmitted again back to the recording devices or emitted from the target, what we need, we require a sensor that is remotely placed, that is not in contact with the object, right? So that will collect and record the electromagnetic radiations, and then the transmission, reception and processing of the information take place, that is the energy that is recorded by the sensors, that has to be transmitted often in the electronic form, and to receive and process the station where the data are processed. So there are receiving stations and processing station where the data is processed, and finally the interpretation and analysis, that is the processed image is interpreted visually or digitally or electromagnetically to extract the information about the object which is under observation. Then the last one is application, that is very very important, that is final element of remote sensing, that that achieve when we apply the information we have been able to extract from the image. So whatever image we get, from that we should be able to extract the information. So that is very important, that is application. So here again the same thing is repeated, okay. So these are the this is how the electromagnetic wave travel. There is a magnetic field and electric field, so it is called as electromagnetic radiation. So electromagnetic spectrum, that is all the radiations when you listen to the radio, when you watch TV, or when you cook something in a microwave oven, they all are using the electromagnetic waves or electromagnetic radiation. So this is how the range of waves, okay, that is radio wave, microwave, infrared, visible, ultraviolet, x-ray and gamma ray. So this is the electromagnetic field, you can say. So here whatever is invisible range, that we can see, okay. So the range is given here, right? So this is the frequency, that is in hertz. 10 raised to 4, that is radio wave. 10 raised to 8 is microwave. Then infrared is 10 raised to 12, 15, 16, 18 and 20 will be the gamma ray. So this is how the electromagnetic radiations, different radiations. Then these are the few examples or few satellite images, right? This is how the satellite images look. You can study the effects, after effects and before tsunami. Here is the image which shows before tsunami how it was, and after tsunami how the area has affected. Right, here also you can see the close view of a image, okay, or area, wherein you can see clearly what was there and after tsunami how it has changed. So like this you can study even a smallest part. This is, you can see there is a runway, right, Mumbai airport, okay. Like this you can see the even the shadow of the aeroplane, that is also being sensed. So the smallest object is also being sensed by the uh, remote sensors, and this works on a pixels, okay, pixel by pixel. When you purchase camera, you go for the resolution, right, image resolution or pixels. So all these images are also work on the same concept. So this is a, there is a Taj Mahal, and this is the Yamuna river, okay. This is a city, okay. These are agricultural fields. So all these information you can extract from a satellite image, okay. So this is a hilly area, okay. Mountain ranges you can see. This is a land and water, okay. This is Mumbai, okay. Even a smallest object can be sensed by the remote sensing. So then in the next class we will discuss what are the applications of remote sensing. Thank you.